Today we are working on the final exam review. We're going to go through Units 7 and 8 today, and obviously our questions are similar but not the exact same number, so that will at least help you with the process. So I've got my MXL open here on the left, and I'm going to go through and work them out on the right. So the first one says we have to find the measure of angle D. Well, if you remember, there was a few properties that were true about parallelograms, and I know this is more than what you need, but just as some reminders, we know that opposite angles are congruent, and we know that consecutive angles are supplementary, which remember means adding up to 180 degrees. So in this particular problem, we have the 116, we're looking for angle D, which is consecutive, which means they have to add up to 180 degrees. So in other words, the measure of angle D plus 116 has to equal 180, and we end up with the measure of angle D being 64 degrees. Let's see if I can zoom in a little bit for you too. There we go. And we'll go ahead and type that in here, and we got it right. Okay, next question. Now if you notice on this one, we're dealing with opposite angles. Well, up here we said opposite angles are congruent. So that means we're going to set these angles equal to each other. 8a minus 4 equals 4a plus 68. We need to get a by itself. The first thing I'm going to do is subtract 4a from both sides. Then we can add the 4 to both sides. And just remember, yours is going to be a little bit different. Same process, but different numbers. And then finally, we're going to take 72 and divide it by 4, and we end up with a is equal to 18. Okay, question number 3. Again, we're dealing with a parallelogram. Another property that we talked about in a parallelogram is the diagonals bisect. So that means from A to the center here is the same as the distance from the center to over here. So we've got 6x is equal to 7x minus 9. Again, we're going to get the x's by itself by subtracting the 7x. And then divide by -1, and we end up with x is equal to 9. All right, number 4, it wants to know, is that a parallelogram? Well, again, we had several ways to prove if something was a parallelogram. 2 of those we said were up there. If the opposite angles are congruent, it's a parallelogram. If the opposite sides are congruent, it's a parallelogram. If we have opposite sides parallel, it's a parallelogram. If we have consecutive angles are supplementary, it's a parallelogram. And we had one other unique, we had diagonals bisect, and we had one other unique one, and that was where it said one pair, and it had to be the same pair, is congruent and parallel. So if we look at this one, remember those arrows means the opposite sides are parallel. So we know it's yes, and it's this last one because both pairs of opposite sides are parallel. Okay, so if you look at this one, all they've given you is one pair, and when we wrote down opposite, it's both pairs of opposites. So in this particular case, it is no, and it's because it only has one pair of opposite sides congruent. Okay, next we need to figure out whether this is a rhombus, a rectangle, or a square. Well, first of all, I can see I've got right angles, so at a minimum, I'm thinking in my mind, and this is question number 6, it either has to be a square or a rectangle because we've got the right angles. And then the second thing, in order to be a square, we would have to know that all sides are congruent, and we don't have that. So my guess is this one's going to be a rectangle. Let's go see. It's a rectangle because it has 4 right angles. Okay, question number 7. This is a rhombus. And if you remember in a rhombus, this line right down the middle, I'm going to see if I can annotate on here. So this line right down the middle, so right down here, makes it such that these triangles are congruent. So I've got this triangle up in here and the bottom one down there, which also means that angles 1 and 2 are congruent and 3 and 4 are congruent. And actually 2 and 4 are congruent as well, because technically, because it's a rhombus, these sides are congruent, so I have an isosceles triangle. So let me pull out the picture that I'm looking at here. This is 112. These two are congruent, which means these two angles are the same measure. I'm just going to label them to be x. So in other words, 2x's plus 112 equals 180 degrees. So I get 2x is equal to 68, which means x is equal to 34 degrees. So that means 2 and 4 are 34 degrees, as well as 1 and 3 are too. I gotta see if I can stop this. Okay, so here we go. 34 degrees, 34 degrees. Okay. Question number 8, we've been given a rectangle, so let's go ahead and draw out just a rough sketch. It doesn't really matter where I start with that first point. It says we have L. The main thing is you either need to go clockwise or counterclockwise. We can't go L to M here. So this is M, this is N, and this is P. And we have information on LN and MP. Well, if you remember, the diagonals are congruent in a rectangle, so we simply need to set these equal. Again, I'm going to get x by itself by subtracting the 3x. I'm going to add the 4 to both sides. 36 is equal to 6x. When I divide, I end up with x is equal to 6, and that's all they're looking for. But now they want the length of the diagonal, so we're going to take that 6 and simply plug it back in here. So we have got 3 times 6 plus 32, and it really shouldn't matter which one I plug it in. I should end up with the same value. I'm just going to make sure that I do. I got 50, and did I get 50 for the other one? I did. So we've got 50 here and 50 here. Okay, the next one says list the quadrilaterals that have the given property. It says opposite angles are congruent. Well, first of all, opposite angles are congruent in a parallelogram, and all of these other shapes are also parallelograms. So that means that statement is true in every single one of those. And if you think about, we actually had a diagram. You might look back in your notes with that packet as well. But like we had the parallelogram was up here, and then we had a bunch of shapes off of there, and every single one of those came from that parallelogram. Okay, next we have an isosceles trapezoid. If you remember, in an isosceles trapezoid, we had a line of symmetry. So that meant if I draw right down the middle here, that angle 1 and angle 81 are the same, and 2 and 3 are the same. So the first thing we've done is we've figured out angle 1 is the same as 81. So let's go ahead and type that in. Okay, then angle 2, took away my little picture here. Angle 2, we have got lines that are parallel here. So in other words, you've got this line and this line are parallel, and we've got this transversal. And if you remember, these angles here are same side interior, which means they have to add up to 180 degrees. I know angle 1 is 81, so 180 minus 81, and I've got 99 degrees for angle 2. Angle 3 is the same thing because we had that line of symmetry. All right, next we have a kite. And again, let's go sketch out a few things. We have a line of symmetry on a kite. So right down here. The other thing you might remember right in here is angle 1 is actually a right angle. Let me see if I can draw that in there for us. So angle 1 is a right angle. So we can go ahead and fill that in over here. And I'm just going to write myself a quick note, because if I go off of this, I'm going to write myself a quick note. I know angle 1 is equal to 90 degrees. Okay, we've got angle, this up here is 39. Well, if we've got that line of symmetry, that means the measure of angle 3 is 39 degrees. And actually, I think I'm going to put it on here, because as soon as I go and click in there, it's going to erase it. So this is question number 11. I figured out the measure of angle 1 is 90. And I figured out the measure of angle 3 is 39. So that just leaves me with angle 2. Well, if you take a look, you've got a triangle over here on the right side. So we figured out this is 90, this is 39, and we know the measure of the angles have to equal 180. So I'm going to do 180 minus that 90 minus that 39, and I end up with the measure of angle 2 is equal to 51 degrees. All right, so let's get out of here. And again, I wrote my measurements down on my paper. I've got angle 1 is 90 degrees. Angle 2 we figured out was 51. And remember, your numbers again are going to be a little bit different, but still the same process. And angle 3 is 39 degrees. Okay. This particular one here. So if you look at this one, to get to K, we went out this amount and then we went out just a little bit more. So that initial amount here corresponds with the 3C, and then point D, we're not moving any up or down. So let's try your answer at 3C, 0. Okay, then point J means we're going out this little bit, which corresponds with this little bit. So that means we are going out D, and we are going down the same amount that we did on point K, which would be negative 4F. All right, the next one. Okay, we have been given the length from T to Z is equal to 6R. So again, here to here is 6R, which means here to here would be 3R, 0, and this distance would be a negative 3R, 0, to equate with the whole distance is 6R. Then up and down, I've been given here to here is 4P. That means this is 2P units up, and this is 2P units down. So the coordinates of point T would correspond with negative 3R, 0. Okay, point P, I'm not moving any left or right to begin with, so that would be 0, and we went up to P. Z is to the right, so that would be a 3R, 0. And then finally the last one, R, again, we didn't go any up or down, so that would be 0, or excuse me, any left or right, but we went down to P. Okay, the next one we have to find the midpoint. So if you remember, the midpoint is we are adding our x's, dividing by 2. We are adding our y's and dividing by 2. So we've got negative 3 plus negative 8 divided by 2, negative 1 plus negative 8 divided by 2. Okay, I'm running out a little bit of time here, so I just paused it. Just make sure you write your answers as fractions, not decimals. Let's check our answer. Looks good. Okay, the last one they want us to do is find the distance formula. Okay, for the last one, your distance formula is on your formula sheet. So I took x minus x and y minus y, m minus 0 is m squared is m squared, n minus 0 is n, and n squared is n squared, and that's as far as I can go.